pre-calculus students, welcome to section 3.2, logarithmic functions. You learned these in Algebra 2. They are the inverses of exponential functions, which is why it's after 3.1, but they have their own use. Logarithmic functions have a lot to do with our physical abilities, the way our heart rate works, the way our memory works. We use logarithmic scales for the Richter scale, for pH scales, right, for decibel levels. And so very important function on its own. So let's refresh. An exponential form is when you have a base A and an exponent of Y, and logarithm is just another word for exponent. That's nothing different, just like you would call a dog a pooch, right? Or a cat, a kitty, right? It's the same. An exponent is a logarithm. So when you see log, go, that's the exponent to help yourself out. So when you have a base raised to a logarithm or an exponent, that results in a solution, right? This is exponential form. To write it in logarithmic form, then, we say log, because it's in logarithmic form, with a base of A, which is below, like in a subscript level, like a little submarine going through the water. Notice that in both expressions, the base is at the bottom, just like all bases are, right? So log base A of the solution equals Y. Notice we said over here that Y was the exponent. And if you just close this off, that's what it says. It says Y is the log, Y is the exponent. And so the way you say this is log base A of X is Y. So let's take a look at the exponential form. 2 cubed equals 8. Notice it's a true statement. There's nothing to solve. We are just putting it in logarithmic form. So let's write log first. The base is 2. The solution is 8. And the log is 3. So we're just placing these 3 items where they belong in log form. Notice log base 5 of 1 over 125 is -3. This is a true statement. Okay, all we're doing is putting it in exponential form. So the base is 5. It says that the log is -3, and that equals 1 over 125. Notice this is true, because 5 to the -3 could be written as 1 over 5 cubed, right, with a positive exponent, which is 1 over 125. Now, your calculator has a log base on it. It's math button in A, but it's important that you can mentally do some problems without your calculator. So let's practice. Log base 2 of 32. So if you have a hard time just going, that's 5, because it is, then say it exponentially for yourself because you're used to that more. When the base is 2, what is the exponent that results in 32? That would be a 5. Log base 6 of 36 is not 6. 6 times 6 is 36, I know that. When the base is 6, what's the exponent that equals 36? 2. Log base 10 of 1,000, right? So what would that be? When the base is 10, what is the exponent that gives you 1,000? That would be 3. Log base 5 of 625. When the base is 5, what is the exponent that equals 625? That would be 4. Log base 11 of 1. 11 to what exponent is 1? That would be 0 for everything. Log base 621 of 621. 621 to what exponent is 621? That would be a 1. The last two are a little harder, right? Log base 2 of 1/2. When the base is 2, what's the exponent that gets you 1/2? Let's look at it. When the base is 2, what is the exponent that gets you 1/2? Well, let's take a look. This is really 2 to the first. Now, this base of 2 is in the numerator. This base of 2 is in the denominator. So let's move it up and change the sign of the exponent to a -1. There we go. This is still a half. And so our exponent must be, oh, I threw my marker, a -1. Here we go. How about log base 27 of 3? All right, so they're saying when the base is 27, what is the exponent that gets you 3? Well, it's got to be less than 1, right? Because 27 to the first is 27, right? So it must be like a fraction. Okay, let's take a look. What if I wrote 27 with a base of 3? Right, there's a 27, right? All right. So here's 27 to some exponent. It's going to get me 3 to the first. So I need 3 times something to equal 1. Well, that must be a third. 3 times a third, right? And maybe you remember that a 1/3 is a cube root, a power of 1 and a root of 3. 27, the cube root of 27 is 3, or 27 to the 1/3 power is 3. All right, common log. With a base of 10, we use that with our scientific notation, and we use that with our decimal system. So when you use the common log, which is on the left of your calculator, log, we don't show a base of 10 because it's so common. Just like x to the first, we don't show the exponent of 1. So without using your calculator, what is log of 100? So if it helps you, write the base in. When the base is 10, what is the exponent? Or the solution is 100, that would be 2. Right? Log base 10. When the base is 10, what is the exponent that will give you 10? 1. Log of 1, 0, right? For anything, when the base is 10, what's the exponent that gets you 1? How about 0.1? What is log of 0.1? Not on your calculator. Notice that 0.1 is 1/10. What is log of 1/10? Here we go. How about if we write 1 over 10 to the first is 10 to the -1? That's still 1/10. There we go. I can see the exponent right there. It's -1. Now here's some properties of any base. Log base A of 1 is 0. We saw that a couple times. Log base A of A is 1, right? If you have a base of A, what exponent gets you A? A 1. Take a look here. We said logs and bases are inverses of each other. So this should cancel out and get us an X. Let's find out why. They're basically saying when the base is A, what's the exponent that gets you A to the X? Obviously X. Here's a 1-to-1 property for logarithms. If the logs are equal, meaning the exponents are equal, and the bases are equal, that must mean that the solutions are equal. How about the natural log? That is also on the left-hand side of your calculator. That is a base of E. So without using your calculator, what is the natural log of 1? It must be a 0, right? If you're unsure with the natural log, just write the base of E. E to what exponent is 1? Oh, 0. Anything to the 0 power is 1. The natural log of E, this is going to be really important to us, super important, is 1. Let's check, because the base is E. What exponent gets you E? A 1. Now, again, the natural log and the base of E are inverses of each other and leave you an X. Or the natural log of E is 1, leaves you with the X. So because the natural log is still a logarithm, all the properties apply. So if the exponents are equal and the bases are equal, then the solutions must be equal. There. And we don't need any examples from the book because everything we did here covers what's in section 3.2. Okay, have a great day.